And we're doing another cosmology segment, folks. Let's get started with the easy stuff before we move into the hard stuff. Are you hitting the hard stuff? Here's where planets are located in the solar system. Today, on February 7th. There's where things will be in 1 week as Mercury swings past Venus to meet us on this lonely side of the sun. Here's where stuff's located in the sky above my head. I'm always interested in that. I like to use in-the-sky.org to create star charts. And we're going to look at a bunch of more stuff here. Let's look at cosmic ray flux. First, we're going to look at the Apatity neutron monitor. There's the current data at Apatity. And down at the bottom is Barentsburg. We will leave links to this site here that has the cosmic ray stations listed. Inconvenient links. Next is the Athens neutron monitor. And we did see some wild swings there in the past, actually yesterday. Wild swings up and wild swings down. And a tiny uptrend over the past 30 days at Athens. Next, Mexico City. And showing similar swings there, so that's interesting, folks. A correlation there in some anomalies in the cosmic ray flux. See if Moscow's sending data yet. And again, please monitor these yourself. Moscow not sending data. Please monitor these yourself. If you're interested in cosmic rays, don't believe the hype. Believe the data. There's the data from Oulu, Finland. Small downtrend over the past 30 days there. No data from DOMB Antarctica and DOMC Antarctica. Quite flat over the past 30 days. And if you're wondering what we're listening to here, it's Molybdenum 99. Shout out to smAsho staff for all your hard work. By the way, you have been paid, thanks to our patrons. And, yeah, this one is named after the radioactive isotope of the element molybdenum. And it's located at soundclick.com/goldencatproductions. 15 tracks in there for sale or for stream. We're also opening up the whiteboard to the public now. If you want to show up here, graffiti it, save our images, or do whatever you like, feel free. It's going to be up for 15 more days. It's got the local chimney. It's got the zoom in of Nat Geo's artist rendition of the Milky Way galaxy. A GIF animation of the South Solar Polar Field area. Other GIF animations and stuff. Even a diagram of what the lattice layers and intercalate layers are like on the liquid metallic hydrogen sun. Let's talk about M31 real quick. Messier Object 31. And why are we talking about that? It's because of smashomash.com/forum. We've updated our Cosmology forum subject thread of the most. So here's one. We've copy-pasted an article here about Andromeda Galaxy, location, characteristics. One image. I guess they're not letting us remote host those images, which is fine, so I put up a larger image there of the Andromeda Galaxy, the most close of the major galaxies. Let's talk about solar wind sounds. Here are some from Parker Solar Probe. We're going to let the audio play from this as we talk about the solar wind every day. I assume this won't get us banned or demonetized on YouTube, but I wouldn't be surprised if it did anyway. I'll try to narrate this for you. As the first portion is the hurricane-sounding Whistler mode waves, followed by dispersive chirping waves. Actually, the Langmuir waves are heard first, then Whistler mode waves, then dispersive chirping waves. Take it away, European Space Agency. Sounds like something you'd hear on the Twilight Zone for sure. There are your Whistler mode waves, which sound more like a hurricane. And you can see some cosmic rays hitting the sensor there, those squiggly lines, as well as you can see Mercury and Venus. Lastly, we have these dispersive chirping waves. And the image you see there is the side view camera on the Parker Solar Probe. There are those dispersive chirping waves. Also, I have included links to this. It's under the astronomy picture of the day section of apod.nasa.nasa. I can't talk anyway. We've also included a recording that I did where I brushed up some of the data here. That's the regular solar wind. Now you hear empty space. Now you hear what a solar storm sounds like. That's a solar storm sounds, folks. And perhaps we'll upload that one to the forum. Let me play that for you again. This is what a regular solar wind sounds like. And the second half is what it would have sounded like yesterday during conditions of geomagnetic unrest. Anyway, let's move on to talk about the mainstream astronomy explanation of what a neutron star is. And there are problems with this, and I'm not just putting this up to criticize it, but in order to understand what's wrong and what's right with mainstream astronomy, you need to understand what it is they're thinking about these things. So we've linked to this YouTube video also about what are neutron stars. Here's a tidbit.
Stars spend their lives fusing matter together. This process begins with the simplest of atoms.
Now, this is a problem in that mainstream astronomy believes that stars are fusing matter in their cores. We see no observational evidence of that, but we see plenty of observational evidence that they're fusing matter on their surfaces and in their atmospheres. So this is one of the many things that we're talking about when we talk about the rewriting of cosmology and astrophysics. The implications of condensed matter stars is, let's just say, serious. Here's another tidbit about neutron stars. This is a white dwarf section, it looks like.
Produces a white dwarf, a spinning sphere of white-hot matter about this.
And this all has to do with things like the HR diagram and being able to calculate a star's mass. And if you don't understand how the sun works, you certainly don't understand how the core of a distant galaxy works. Stars have fusion cores and are made of balls of gaseous plasma. Aw, man. Observations don't hold up to that, so let's move on to more things that debunk these theories, shall we? How about an ancient monster galaxy in the very early universe? This galaxy is believed to have formed when the universe was only 1.8 billion years old. If you're wondering about the mainstream understanding of the age of the universe, it's believed to be about 12 billion or 13.5 billion years old. So we left links to the article here. This is yet another thing that debunks basically most of cosmology, as a galaxy this massive should not be behaving the way that it is, as it's not really producing a lot of star-forming areas. In fact, it's producing 0 star-forming areas, which makes the evolutionary path of galaxy XMM 2599 unclear. Do these astronomers look a little uneasy? Well, we're not looking for people to be fired from their jobs or anything like that, folks. We just want to see what's actually going on in cosmology. So it's an interesting candidate for more research. XMM 2599. Inactive galaxy at an age that is inappropriate for that level of galactic evolution. In other words, galaxies probably don't evolve the way mainstream thinks they evolve. Now, let's talk about assumptions, built upon assumptions, built upon assumptions, built upon assumptions. It's a stellar fight with a beautiful outcome caught by ALMA. Now, they didn't even resolve two radio sources here, but they claim that this is formed by two stars, as collisions are the main tool in the mainstream astronomical toolbox. So I'm just going to leave it there on this one, as we can clearly see jets. You can see a blue jet over here. That's the one that's oriented more toward you, toward the observer. And the red jet here is the one oriented more away from the observer. And this looks like one star under a period of extreme activity to me, but let's just play a clip from the video. It's just a bunch of music. And notice the way it says jets fueled by outflow through the layers, adding to the complexity of the gas cloud, as jets of protons are in charge of this operation, apparently. And let me just use that moment as a moment to segue. Actually, first, again, we linked to the SciTech Daily article here, and this is the binary HD 101584. I'm not sure if this one is actually an assumed binary. Yeah, this is an assumed system here. Olofsson and his team did not know what happened to in the double star system. Oh, they now know it was akin to a stellar fight. As the main star puffed up into a red giant, it grew large enough to swallow its lower mass partner. In other words, they're resolving one radio source there and making all sorts of assumptions as to where that material came from. And the only explanation they can come up with is a star must have eaten another star. So that's never been seen. We've never seen a star eat another star. And this is just one other series of assumptions. It looks like a series of possibly like nova shells. And I would need to see this at various different focal distances to even make a guess as to what's going on, other than a star is spitting out some jets and some of the material is likely raining back down into the system. Now let's consider the idea that stars and indeed galaxies behave like fountains instead of like vacuums, as we have repulsive as well as attractive forces in the universe. If you lived in this bird bath, you may have trouble seeing the fountain that's occurring, as the sun's jets are blasting some material well out into space, and other material is likely raining back down into the interplanetary system. And ultimately, we don't know if these objects are losing or gaining mass. When you look at a thing like a blazar, your perspective is from inside of that relativistic jet. All it does is look very bright. Keep in mind, the outbursts from these things come in pulses, as things tend to be a bit irregular in space on certain scales, as well as very regular on other scales. Let's just talk about mass real quick. And what we're talking about is a collection of incoherent particles, parts, or objects regarded as forming one body. The physics definition, that is. Mass, right? Ask a physics teacher what mass is. And strap on your safety belt, because it's going to be a long, long ride that he's going to take you on when he tries to convince both himself and you that he knows what mass is. Is it a warping of space-time? Or is it a collection of protons and neutrons? Now, I brought this up because this is a very interesting article, and I don't believe that we understand whether or not the sun, the Earth, or the galaxy are gaining or losing mass. And this article really falls all over itself with the same sort of thing. And I just brought up this image because this should be very interesting to some of our viewers. This is data gathered on a meteorite chart. So this is from 1994 to 2013, the small asteroids impacting Earth's atmosphere and disintegrating to create very bright meteors. So I'm sure somebody will be interested in that. And this Universe Today article just goes on and on about all the different mechanisms that are known to cause mass to go up and cause mass to go down. And ultimately, we really don't know whether the galaxy, the planet, or the local yellow dwarf are gaining or losing mass. Let's talk about an interesting article recently coming out here about a double nucleus galaxy. And you see all that orange stuff? Those are massive hydrogen clouds. So shout out to Alan Lawrence from Iowa State, as Iowa's in the news lately. And this is the kind of news that we want to hear out of Iowa. Anyway, NGC 4490 is a very interesting double nucleus, and there is a massive gas cloud surrounding it. Both nuclei are similar in size, mass, and luminosity, or alleged mass. And keep in mind that this is all based on their movements, most likely. The paper is published, and it is linked in this article, which we linked below this video. And as a further teaser, Struck, who studies colliding galaxies, said double nucleus galaxies are very rare, especially in smaller galaxies such as this one. And he said astronomers think a double nucleus could contribute to the buildup of supermassive black holes found in the center of some galaxies, as this is a common explanation. But what does it really come down to? Where did all that hydrogen come from? And there's an image of the Cocoon Galaxy. And we've also left links to the Science Alert article about it. Galaxy NGC 4490. Lots and lots of hydrogen, folks. Where do you think all that hydrogen came from? What a segue. Are you familiar with Dr. Pierre-Marie Robitaille, host of the YouTube channel Sky Scholar? Are you aware that he took out an advertisement, a full-page one, in the New York Times Sunday edition, at his own personal expense of about $300,000 USD? Are you aware that he holds the record for the highest resolution MRI ever done? Professor of Radiology at Ohio State University Department of Medicine, Dr. Pierre-Marie Robitaille. We've left links to the Science Woke page, as well as to his page at Ohio State University. If you'd like to contact Dr. Robitaille, please feel free. And maybe I'll give him a call later and tell him I want him on the show to talk about the implications of sound observational theories. Solar Orbiter 2 is launching today, it looks like. And I'm not sure if it's launched yet or not. I got sick of trying to navigate the websites. But we're super excited about Solar Orbiter in that it'll be getting close-up images of the solar poles, where the real violent stuff happens, unlike down here on the equatorial plane where all the mild things happen. So it's come out of its clean room, it's on the launch pad, or it could be launched already. I could not find the right information there. But it's going to be an interesting couple of years for solar data here, as the Parker Solar Probe is already out there, and now the Solar Orbiter is going to be orbiting the polar regions. Yes. So it's going to be amazing. We're going to get data about those proton streams that are constantly coming out of the poles of the sun. So up until now, only the Proba 2 mission has been able to photograph the solar poles. And we left links to that article too. This is the New Scientist one. The Proba 2 mission is going to be superseded. Let's get back down to Earth a little bit. And it looks like the auroras must have died down, as we were in a geomagnetic condition of unrest yesterday. A little bit of solar wind looks like it's still going on there. And without looking at any more data, we'll just let that play through. That is the 30-minute aurora forecast. Next, we'll talk about an article real fast about fast radio bursts. It's been discovered that some fast radio bursts, at least one of them, appears to repeat at a very faint level after the initial huge spike. So the size of these radio bursts is equivalent to hundreds of millions of stars, all emitting radio all at once. It's very difficult to trace them back to their point of origin. Fortunately, this one, FRB 171019, is shown to be still repeating. So could be some sort of insight into what's going on with fast radio bursts. And I should actually include this on smashomash.com/forum as the most repeating radio burst. So read that article too if you're interested about fast radio bursts. Head to smashomash.com/forum and don't be afraid to create a topic. Thanks to all the new viewers who did. If you enjoy the content, please press like and subscribe. Leave a comment wherever you're viewing, as we are on various platforms: YouTube, BitChute. And we're starting to put up some exclusive content in all the different places, such as this morning's video of the local yellow dwarf on 171 angstroms. Are you familiar with the smAsho MASH mission? It's to assist, study, and report the ongoing formation of a unified theory of physics. And tomorrow, we are planning to do a video about just that, featuring Eugene Bagashov. So look for that. If you would like to support the mission, please consider becoming a patron. It's patreon.com/smashomash. We've only got 2 tiers, and we're considering adding a 3rd soon. Please consider joining at the gold level, as you'll get all kinds of perks like free music. Thanks, Smash Team, for tuning in. Leave a comment. Share on your social media. Tell your friends. Tell your foes. Happy birthday to Mothra! And we've got a forum section. You can send happy birthday wishes to Mothra. My mom. Love you, Mom. Happy birthday. Give me a call. Again, check out smashomash.org, and welcome to the Neo-Renaissance, folks. It'll never be now again. And let's look at some bonus features here. Solon.info on February 1st has updated its lots of data. And I would note that if you look down here, see that little tiny bump right there? That is exactly when I predicted cycle 24 to end and cycle 25 to begin. Let's keep watching the data and see if I was right or not, as I called August or September as the moment. Now, we have seen a very low radio flux. Back in December, we saw the radio flux get all the way down to, and we're talking about the 10.7 centimeter radio flux here, it got all the way down to 64 for a brief period. But notice the solar polar fields shown down here in red and green. See the way they've crossed? You see the way that black line is rising up? Well, this blue line is now looking like it's ready to flatten out. So that's something to keep an eye on. And when I say keep an eye on, the pun is intentional. Here's the intensity gram of the local yellow dwarf, just to show you that there are no sunspots right now. A couple active regions in the south. Here's a colorized magnetogram to highlight those. This one very far south down here, as well as that one there. That could turn into a sunspot, folks, although we don't see any kind of significant activity. A little bit of magnetic organization going on near the equator also. And let's look at one bonus feature and close this thing out. And this is the 48-hour view here of the sun, 131 angstroms. Pretty low levels of activity, folks. Thanks for tuning into the Cosmology segment. Look for another video coming out pretty soon in the form of the daily space weather. Also, please visit the links below, and we'll be talking to you soon.